Okay, for your quiz on Friday, it will be on 3.3. Please pay attention to each directions. Each instructions are going to be different. On questions 1 to 3 is telling us to evaluate. We're not solving, but we're evaluating the function when x equals -2, 0, and 5. You could do a table. Yes, you could do a table. It's perfectly fine. But the interest of time, we're going to just substitute and plug in what we have. So we said that it was going to be what? It was given to us -2, 0, and 5. So we have f of x equals -2 minus 3. What is the answer to that? -2 minus 3 gives me -5. Correct. -5. Then we have f of x equals 0 minus 3, which f of x is -3 when 0 minus 3. And finally, the last one, we have f of x. We have 5 minus 3 gives us the function of f of x gives us 2. On the second question, we have g of x gives us -2x. So we're going to plug in, which is -2 times -2, which gives us, correct, g of x gives us +4. Finally, g of x gives us -2 times 0, which we already know anything multiplied by 0 is going to be 0. And finally, we have g of x is -2 times 5, which gives us -10. Here, they're just telling us to do what? Use substitution, where we're going to plug in what x equals. Fine. Remember to always read the direction. Here we have h of x, which gives me 5 minus 3 times -2. What's the first thing we need to do? PEMDAS, right? PEMDAS. So it's going to be distributive. We're going to distribute -3 to the -2. -3 times -2 gives me +6. So 5 plus 6 gives me h of x equals 11. Then we have h of x equals 5 minus 3 times 0. Again, distributive property, -3 times 0 gives me +0, which 5 plus 0 gives me h of x equals 5. And finally, we have h of x equals 5 minus 3 times 5. We're going to do distributive property. -3 times 5 gives me -15. What is 5 times, 5 minus 15 gives me -10. And that is your answers just for questions 1, 2, 3. Remember to do what? Direction, read directions. And number 4, it's telling us, let's see, function of c of t be the numbers of who? Numbers of customers in a department store, where t is the hours after 8 a.m. We're going to explain the meaning of each statement. Let me expand here with A. So it's telling us at what time do we start? 0 will be the start time of 8 a.m. So at 8 a.m., how many customers were there? At 8 a.m., there were 10 customers in the store, correct? And B is telling us 6 hours after it opened. What time would it be 6 hours after it opens? So all we're doing is adding what? 6 hours to 6 hours to, correct, 6 hours to 8 a.m. So what is 6 hours to 8 a.m.? Correct, 2 p.m. And 7 hours after 8 a.m. gives me 3 p.m. So we're able to say that the number of customers at 2 p.m. was the same as 3 p.m. And question C, we have what? C of K equals 0. All they're telling me here is that at a certain time, do we know what time? No, K is a variable, so we just know that it represents a time. So there was what? 0 customers, correct? So there was a time when there were no customers, correct? And D, again, 4 hours after 8 a.m. is what? 12 p.m. is greater than 3 hours after 8 a.m. is 11 a.m. So there were what? There were more customers at noon than at 11 a.m. Okay? And number 5 through 8, they're telling us to solve for who now? Now we're solving for x. We haven't been given x, but so that the function has the given value. Did they give us the function value? Yes, which is what? Given us as f of x equals -24. So if I was to rewrite this equation, remember that f of x is the same as what? F of x is the same as your y, which is the same as your output. Okay? It's the same thing. Just remember that. It does not mean it equals x. It just means that the function will be of x. So here we have what? -24 equals 6x. What do I do now? We know that a variable next to a number means division. So we're going to, remember, we're solving for who? For x. So 6 divided by 6, I'm left at 1, which is the same as x. And -24 divided by 6 gives me -4. And that is your answer. And number 6, we have, again, they're giving us g of x, which we're going to plug in right under this, which is 15 equals -10x. Again, we're just going to do what? Divide by -10 to cancel out. Always leave your variable positive. So we have here x equals 15 divided by -10 give us negative 1.5. And that's our answer for number 6. Number 7, again, we are given f of x equals 4. So it's 4 equals 3x minus 5, which we need to do isolation, right? And move over everything inverse. Inverse of 5 is plus 5. 9 equals 3x, and correct, we divide. So x equals 3. Yes, correct. It's the same as two-step equations. But we need to know the difference. Number 10, again, they're giving us h of x gives us negative 2. So we have negative 2 equals 14 minus 8x. What do we do first? Pam does remember backwards. So we're going to have negative 14 on, and negative 14 minus 14. So we have negative 2 minus 14 gives us, yes, negative 16, which equals negative 8x. I'm going to divide by negative 8, which our answer becomes positive, correct, equals x. 2 equals x. So that is for number, correct, number 8. In number 9 to 12, we're going to graph the linear function. We already know it's a function. And what is the function equation? Correct. Y equals mx plus b. Where what? X, let me do another color. Where x is our ordered pair and y is our companion, right? So we have x, y. Eventually, we're going to learn what m and b are. But at this moment, we just know that x gives us our ordered pairs and y gives us our y-axis, correct? X-axis and y-axis. So here we know that it's telling us that, in number 9, that we have r of x equals 2. If you recall from the last lesson that we took the test on, we established what? Let me do, not highlighted. R of x is the same as what? Y, which is our output, correct? Yes. So here we could just simply say what? That y equals 2. And again, the previous lesson we established that y equals 2 is the same as a linear function. Because we know that in y equals mx plus b, we're able to see that we still have our y here. We have a 2, which that could be with our b. Do we have any x? No, so that is going to be 0x plus 2. It's plus 2 because the 2 over here is positive, correct? So what can we say? That our ordered pairs is going to be what? X is going to be 0 and y is going to be 2. Did I need to create a table? No. So we're going to graph it. We know that its ordered pair is going to be 0, 2. If I graph it, I am left with I know it's a little bit crooked, but no, a lot, but bear with me. This is y, and this is x. We know that the ordered pair that we established is 0, 2, correct? So I'm going to go, this is 1 and 2. We know that this is the origin, which is 0. So here is our point. And it's going to be a straight line. And that's our answer. There's nothing else to do. We do not need to create a what? a table. Correct. So we have what? R of x equals 2. So think about it this way. Is this true? If I plug in, let me see, if I do here, what is that order pair there? That order pair tells me this is 1, 2, 3, 4. 4 what? 2. If we plug in an R of x when x equals 4, is it 2 for our output? Yes, which is what? Right there. So that means that any number on that point, on that number line here, will be the function. Correct. We continue here where we have q of x equals -3. Do we have to do a table here? Yes. Why? Because now we're given x, okay? We are given x, so we have to, our table, we're going to have what? X. We have to do our order pairs. X equals q of x equals -3x. And our output is going to be q of x, which is the same as y, right? Yes. So what numbers are we going to use? Remember, I always told you, use low numbers so that when you are multiplying or even adding your equations, dividing or, yes, subtracting, you're not doing big numbers, especially when you have to do what? Graphing it. So we're going to use -1, 0, and 1. We already know that -3 times -1 gives us +3. Then we have -3 times 0 gives us 0. And -3 times 1 gives us -3. Did we use substitution? Yes, we substituted what? All the order pairs given where? From our x that we decided. So what are our new order pair? What our order pairs are? -1 and 3, 0 and 0, and 1 and -3. So now I'm able to graph. I'm ready to graph. You don't have to do the order pairs. I just like to rewrite them so I could see what I'm graphing. So we're going to have y here. And we're going to have x here. So the first point is -1 here, and 1, 2, and 3. Let's do it in black here. Our second one is what? 0, 0. We know that's the what? Right there in the center where both the x and y coordinate meet. Axis meet, correct. Then we have 1 and -3, which is around here. We know that this is -1, -2, and -3. Can I graph it now? Yes, I am able to connect it. And we have what? Equation means q of x equals -3x. All right. Yes. In number 11, I know you guys don't like fractions, but these are real numbers and we see them constantly, okay? We see them constantly. Do not be afraid. I'm going to create a table. We have, we said that it's going to be x. I'm going to have g of x over here, and we know that this is our we're going to have -1, 0, and 1. I'm leaving space for what? For me to solve it. So we have 2/5 times -1 minus 3. What is 2/5 times -1? just means that our equation becomes negative minus 3. I already know it's minus 3. All I'm going to do is 3 over 1, then find the what? Because 3 divided by 1 is still the same. I'm going to find the common denominator, which is going to be times 5, correct. So I have negative 2/5 minus 15 over 5. And what is negative 2 minus 15? Negative 17 over 5, correct. Can I turn that into in mixed number? Yes. Which, how many groups of 5 can I make in 17? 3, correct. So it's negative 3. We keep our same denominator and the difference is 2. Are both numbers correct? Yes. But for the purpose of graphing, I would turn it into a mixed number. Now we have what? Now we have 0. Maybe I should erase this. Okay, it's not erasing, so let's not waste your time here. We have 2/5 times 0 minus 3. We already know that distributive property, that becomes 0. So it's 0 minus 3 gives us negative 3. And finally, the last one, we have 2/5 times 1 minus 3 gives us 2/5. No, it's not going to be the same. It's not the same as saying it's positive 7 over 5. We have 2/5 minus 3 over 1. I'm going to continue to do what? Find the LCD. So now we're left with 2/5. Let me write the 5 a little bit neater. 2/5 minus 15 over 5. And what is 15 over 2 minus 5? Negative 13, correct. Negative 13 over 5. Can I do this as an a mixed number? Yes. How many groups of 5 can I make in 13? Negative 2 what? 3/5. So if you notice, it's still negative, but it's not the opposite. All right, so now we have the order pairs what? We have our order pairs as negative 1 and negative 3/5. We have 0 and negative 3 and 1 and negative 2 and 3/5. Okay, let's start graphing that. Let's do our graph over here, which this is going to be y, and this is going to be x, correct? Yes. Okay, we have, now let me pick another color. This is when negative 1, negative 2, negative 3, 1, 2, 3, negative 1, negative 2, negative 3. First one's negative 1, which we know that negative 1 is over here. Negative 1 with what? With negative 3/5. So that means that graphing it, this is my negative 1 over here, and my negative 3 is negative 3/5. So it's going to be after what? After the 3. So it's going to be somewhere around here, correct? Yes. Then we have what? 0 and negative 3. That's our next point. And then finally we have 1 and negative 2 what? 3/5. So it's going to be positive 1. So it's going to be here, and it's after a 2, right? I'm going to expand this so you guys could see it. It's going to be somewhere 3/5. Going to be close to here. Obviously, it does not need to be precise. because we don't have fractions here. We don't have the fraction coordinate plane. Okay, so now I'm ready to do the line to connect them. That's our equation, which that gives us g of x equals 2/5 x minus 3. Okay, just make sure you guys review for this test on Friday. I'm not including 3.4. I know it says 3.4. I would rewrite that after, but it's just on 3.3.